So fine. Okay. Do I need to now solve for x with you when u equals?
Yeah. What do you get?
And I will get x is equals to u minus 5/2.
2u minus 5 over 2. Yep.
And then with my equation, do I then do so u minus 5/2 times by u to the power of a half?
I see what you're saying. So, like, yep, u to the half. And then u. Maybe I'll write this as a half u minus 5 over 2.
And now I get a bit stuck here.
This is dx. We need it to be du. Any idea what you do there?
I'll just 1 over that.
You have to differentiate this thing to get du dx.
So that'll be 2.
That's going to be 2. And so du equals?
A half.
Oh, it'll be 2 dx.
Oh, yeah.
And so dx is equal to?
Du over 2.
Yeah, I'll just write it as a half du.
Yeah.
And so
does that mean that a half du is the same as dx? Yeah.
Yep. And so, yeah, now we have it in terms of, hang on, I forgot the half. And so, yep. What's next?
And so now do I now need to integrate what I've got there?
Yep. Because you couldn't do it before because it was in terms of x, like with respect to x, but then you changed it to u, so now you can do it.
So do I now have so do I need to take them step by step and integrate it?
You could expand the brackets.
Which will give me a half u to the 3/2 minus 5/2 u to the half.
Yeah.
Times the half as well.
Yeah.
Okay. And now to integrate that will be so am I doing a fifth u to the 5/2?
Hold on. You have to expand the half as well. Or, okay, you could do it at the end, I suppose. Yeah, go on.
So a fifth u to the power of 5/2.
A fifth u to the 5/2. Yep.
And also then minus 5/3 u to the 3/2. And then I need to times that by half, both of those.
Yeah.
And so it'll be a tenth, yeah. And then for the next one, just minus 5/6. And yeah.
C over 2 plus C. You did that a bit easily. I just want to make sure. So u is equal to that. U minus 5 over 2. Yeah, that looks alright. And so that's x. You replace that with that. You replace that with u to the half. Yes. Hang on. There's a part B. We have to use this thing. Alright. Oops.
Okay, and so here we are saying that u squared equals 2x plus 5. Do we need to now solve for x?
I just want to see what happens when you sub it in. Oh, okay, yeah, go on. Solve for x.
And so that will be u squared minus 5 over 2.
U squared minus 5 over 2. So I'll do it like that for index 1. Okay.
And do I now do a half u squared minus 5 over 2 times by u squared to the power of a half? Or just, I'm assuming that's just u.
So that's going to be u. And
Yeah.
then the other one is that.
And do I now need to do the dy over, dy over dx equals to
Well, it's usually du dx.
Sorry, du dx, yeah.
Or I tell you what, let's use this one. See this one that we rearranged?
Yeah.
Let's do dx du with that.
And so that would be, so will that just be 1?
Derivative of a half u squared. Something else is there?
A half u squared. Oh, sorry, that'll be u.
Yeah, it's like 1u.
And do I now need to do du times du equals dx?
Yeah, u.
Just,
u.
yeah.
Yeah.
And so do I now, end that same integral equation we did earlier with u du?
Yeah.
And should we now expand that?
Yeah, I think it's just going to be the same as anything else. So that's going to be u squared, a half u squared minus 5 over 2 with respect to u. A half u to the 3 minus 5 over 2u. And so 4 to 1 over 8 u to the 4 minus 5 over 4 u squared plus c. But is that different from the previous one? It's going to be different, isn't it? It's very different. Okay. All right. So that was A. And that is B. Hang on. So A is alright. Let's see. Yeah, that's 1 over 10 u to the... That one's good. And then this one, u squared is that. Ends up being the same. They said u is equal to the square root thing. Yeah, I don't know. Not messing around with it. What were they trying to show us here? Don't know what they were thinking with that. Alright. They only ever give you one substitution. Don't know what they were doing with that second one. Okay, here's a trig one. Hang on a second. So that's kind of a normal type. I think you get the idea. All right, how are we doing trig?
Okay, so we know that sine u is equal to sine x plus 1. Oh, fine. So if we say u is equal to sine x plus 1, should we solve for x? Or
Yep.
And will that be x is equals to arc sine of u minus 1?
Yeah, I don't like that though. Let's see. So x is equal to arc sine of u minus 1. Don't like that one bit though. Let's see what we can do. This is a different thing, is it? This is a different thing. They call it integration by substitution, but I think it's very different. Let me see. If you integrate, yeah. So we have to end up with 1 plus sine x cubed. All right, hang on. That's a totally different thing, but I want to come back to that. It's different. The first one is similar. Let me think. Maybe I'll start with the first one. So let's start with the first one, because it's kind of a non-true. They're not saying by substitution. They're not giving me the substitution, and they usually do. Okay, let me see. I think you let. Oh, so you're just making up your own substitution, is it? X plus 1. That doesn't strike me as being very difficult. Hang on. Part A. I think it's very easy. Seems fine. Okay, maybe I'll go back then. All right. It's just it's a different thing, but they call it the same thing, but it strikes me as totally different. So u is sine x plus 1. Let's think about this a different way, unless I'm wrong. What is... So if we were to sub this in, what would you get? No. Tell you what. So this bit, fine. And we have u cubed with respect to x. Let's see. Let's try next thing. What would be du dx?
So is that going to be cos x?
Yep. So du dx is cos x. What's next?
Making... Do we need to do like dx equals?
Yeah.
And so will that just be dx is equals to du over cos x?
Yeah, and I'll write it as
1 over cos x, yeah, times d.
Yeah. Oops. Du. And go on. What is next?
Do we add that to the end? So we've got cos x sine x times u cubed times 1 over cos x.
Yeah. Let's see. We stick it on the end. Okay, what's next?
We expand the brackets.
Okay, what do you get?
Will we get u cubed cos x sine x over cos x?
We will, yep.
And will that then simplify down to sine x u cubed?
Yep. Go on.
And I think that's to integrate that. Can we just do we need to use product rule or something?
You have a mixture of u and x. You want just u.
So if we, well, I need to do like the u minus one. No, arc line of u minus one. Or
not arc sine. U minus one.
Oh yeah, sorry, yeah. So we now have u minus one times u cubed, which will then be u cubed. Oh yeah, u to the power of 4. Sorry, minus u cubed. Which will then become a quarter. Oh no, that'll become a fifth u to the 5 minus a third. Oh, sorry, even a quarter u to the 4 plus c.
Well done. Let's see. So you avoid arc sine and arc cos because then you lose the negative answers, and also I don't know how to integrate arc sine. Yes, something that happens a lot in these integration by substitution is that they've kind of made it so that it works out for you. So like 1 over cos x times cos x, and they cancel each other out. If it wasn't for that, I don't know what we would have done, but they kind of make them so they work out in the end. Right, we're good. Wasn't quite what I thought. Right, very weird. How about this? Or maybe before we do that, maybe I should just do one more. Yeah, let's do B. I think A is gonna be fine.
Okay. So
see, they give you the substitution. Let u be equal to, what do you think the substitution is going to be for B?
Would it be like let u equals to 1 plus sine x?
Yeah, that's usually what they do. Okay.
And so now am I going to do so u minus 1 is equals to sine x. Along with that, do I need to differentiate du dx to get just cos x?
Yeah.
Okay, and so now if I do du over cos x equals to dx, or even 1 over cos x times du is equals to dx.
Seems very similar.
And now if we just do, so we have the same equation, but this time if we do cos x times u to the half times 1 over cos x. And that here I'll have, and then I'll end up getting just, so we've got cos x over cos x, which is just 1, so will I just have u to the half here?
Yeah.
And so that will be 2 over 3 u 3 over 2 plus c.
Yep, except c's will cancel because this time it is definite integration. Oh, I think that's one.
I'll just put that into my calculator.
No, I got it wrong. You see these pi over 2 thing?
Yeah.
That is the bounds for x. We changed it to u.
So we need to now change that back to x.
No, it'd be easier to change. Would you be onto something with that? I wonder if that would work.
Oh, I know what we need to do. We need to do so arc sine of u minus 1 pi over 2 and 0.
Hang on.
So
yeah, okay, go on, do that.
or maybe actually even other way around, sorry. So is it supposed to be 1 plus sine pi over 2?
Yes, I don't, yeah.
Yeah.
That arc sine. Stay away from that.
Yeah. I'll put it back out there. So. Do I need to change it to like pi because we got no, sorry, to radians because we've got pi.
Yeah.
And so now so for 1 plus sine shift pi over 2, I got 2.
And the other one will be 1 because it'll be 1 plus sine of 0, which is 0. And what would you do then?
I would do put in sub in 2 for the u and 1 for the u, find the difference in each other, and then
yeah,
and then
yeah, great, and that'll be your answer. Let's see. Let us see. So you could do this the other way where you swap u back, I think. So u was 1 plus sine x, and you could do it that way. I prefer this way. I think is much better. The subbing the limits into 1 plus sine x and changing them to the u ones, and that happens when you change dx to du. So they had a little extra thing. Other than that, I think you're good. All right, I'll now go back to this strange one. How about this?
Okay. So I'm gonna assume here it's gonna be something like u is equals to 1 minus squared. Or even is it just gonna be 1 u equals 1 minus x?
So where is this arc sine x coming from? Let me try something crazy here. Maybe this is very wrong. Sure it is. Let u be equal to sorry. Let x be, I don't know, be equal to cos u. Here's what I was thinking. You would get 1 minus cos squared u. What is that same as?
1 minus cos u, cos squared u, is that the same as 1 minus sine 1 minus sine squared u?
This is the whole thing. What is 1 minus cos squared u same as?
Sine squared u.
Yeah. And so simplify.
And that will just be 1 over sine squared u. Oh, that'd be 1 over sine u.
Yeah, 1 over sine u. What is, oh, hang on, we need the dx thing.
And so now, for the dx thing, are we doing du of dx of one of these equations here? Or?
So this one up here dx du?
Which will be minus sine u.
So that's going to be minus sine u.
Oh, and to make it, and we need to then just do, so dx will be minus sine u times du.
Yeah, so then dx is replaced with minus sine u du.
And so now we just do minus sine u over sine u.
Yep.
Which will be just minus 1.
Mm-hmm.
That will become minus u.
Yeah, so that's minus u plus c. What was u? Aha. If you make u the subject for this one up here, what do you get?
Arc cos x. Yeah.
So u equals arc cos x, and it would be minus that plus c. We were supposed to get arc sine. So okay, so I should have made that let x equal sine u, because I was thinking it would change to like 1 minus cos squared u would become over sine squared u. That's what I was thinking, how to get the sine. Let me see. Yes, so they let x be equal to sine instead of cos. All right, that's what we'll do. If they want arc sine, we'll let it be sine. It's not as bad as I thought. So you just do the exact same thing, but letting it be sine instead of cos. I'll just want to see if they have another one of these arc sine. Man. Oy. The cos one, kind of. Suitable substitution. Wow. Okay. Well. Okay, they don't have that one. They have another trig one. Let's see. Right, let's try this trig one. So how do we do this?
So if we do that, do we solve the x?
Let's do that if we need to, because then we would get the arc cos, and I want to avoid that if we can.
So are we going to do we made it equals to 447 and 480.
They kind of told us the answer, and we just have to show that. So just do it as normal.
So I think, do I need to change it? Yeah. Do I need to make sine cubed x to be equals, or even make, yeah, sine cubed x to be equals to cos squared x?
Well, they're not the same. Let's see.
So if I, sorry.
So let's say cos squared x, what can you replace that with?
U squared.
Yeah, so, I don't really know how these things are going to go. So let's just put in what we can. All right, what can you put in next?
Could I do like u equals to square root of 1 minus sine squared x?
I suppose you could, but I don't like this square root stuff because I think it would be plus or minus.
Okay.
The other thing, so that's the easy substitution. The other thing we always have to do is replace the x with du. So let's do that and see what happens.
Does that mean I need to integrate the left equation?
Differentiate the substitution.
Yeah, and so that will be minus sine x.
Yeah.
Yeah, and then we do dx is equals to minus 1 over sine x du.
Yeah.
And so now we have sine cubed x times u squared times minus 1 over sine x.
Mm-hmm.
And so now if we do like minus sine cubed x over sine x,
Mm-hmm.
would that then give us minus sine squared x times u squared?
Mm-hmm.
And should I then change u squared to cos x, cos squared x, or?
You should go the other way. So we're getting rid of x's, replacing them with u's.
I'm not sure what's doing here.
So in the beginning, we had sine cubed x, cos squared x, and dx. So we replaced cos squared x with a u. We replaced dx with a u. So how could you replace sine squared x with something to do with u?
Oh, will that be just minus sine squared x? Will that be... do we need to use the formula sine squared x plus cos squared x equals 1?
Yeah.
I think it'll be 1 minus u squared.
That's great. 1 minus u squared. That's u squared. Yep.
And so we've got minus 1 plus u squared times u squared, which will be minus u squared plus u to the 4.
Yeah.
Which will then become minus a third u cubed and plus a quarter u to the power, or no, plus a fifth u to the power of 5. And then I need to sub in just pi over 3 and 0 for both u. Oh no. We now need to do, so we've got u is equals to cos x. Do I need to do cos of both pi over 3 and 0 to get the two values I need to be subbing in?
Yes. So I think this one is 1, and then the other one, whatever that is. Yeah, and you would sub those in and get 47 over 480. Let me see. So it's a half. Or maybe I'd do the 1 up there, the half down here. And yeah, so for this one, you might get away with actually just doing like sub in the half, then sub in the 1, and they told us what the answer should be. And so you could just write that at that stage. Wait, I should sub in just 1 first to take away the smaller one. A half. Plus a fifth. A half to the 5. And then that's equal to 47 over 480. Maybe that gives you like 1, 2, 3, 4 different things. So, oh no, I think, well, to show that, who knows how much they want. Yeah, they showed 4 different things for it. A half and 1. Great. Yeah, so big picture is you have a bunch of x's. Like if they ask you to integrate that, you wouldn't know how. But if you substitute like a dummy variable u in replace of something, it goes from being like trig integration to something much simpler. Great. Any questions about that?
No.
Okay. That's the trig stuff. All right. I saw like a long exponential one. Let's try the exponential one, the bottom one.
Okay, so I think first of all, I need to do find the differentiation of e to the x?
Yep.
Which is that just e to the x?
Yep.
And so we've got du over dx is equals to e to the x.
Mm-hmm.
And so 1 over e to the x times du is equals to dx.
Hold on.
And so I don't need to then times 1 plus 1 over 1 plus. Oh no, because we've got u. So that just gives, am I now doing u times 1 over 1 plus u? U.
Okay. Excuse me. So 1 over 1 plus u.
I'll get u over 1 plus u.
And so what is 1 over e to the x the same as?
U.
Nope.
1 over u, 1 over u.
Yeah.
And that will end up giving us 1 over u plus u squared.
U plus u squared. Yeah.
Should I make that 1 over u time plus 1 over u squared?
Long way would be partial fractions. Integrating it that way. What is... There's another way to think of it is if you could write it as u plus u squared to the minus 1. What would happen if you integrated that?
It would become 1.
Minus 1 plus 1?
So
yeah, you're right. It'll be to the power of 0 and it'll all become 1, which is kind of nonsense. Any idea what happens when you integrate something like this with a denominator?
Does it become squared?
What is the integral of 1 over x with respect to x?
Ln x.
Yeah.
Yeah. And I'm assuming here it's going to be like ln and then magnitude of u plus u squared.
Ln, yeah. Okay. And this is...
I then do sub in ln 6 and ln 2 into e to the power of ln 6 and e to the power of ln 2 to get my new two values.
Yeah, and if you put e to the ln 6 in your calculator, it'll say 6, and e to the ln 2, that'll be 2, because e and ln cancel out.
And so here I just need to do, so subbing in 2, 6.
Yeah.
Yeah.
And this one, maybe I'd better. They want an exact thing. What is that? That's ln 36, ln 42 minus ln 6. What is that?
That will be I don't get an exact answer.
Sure don't.
Pardon?
Sure don't. You're gonna have to do it manually.
So are we gonna do ln 42 over 6 or something?
Well done.
And that will be that would be ln 8.
That's ln 8. Yeah, that's great. And that's what they wanted there in the form ln something. Press to put in ln 8.
Ln 7. My bad, ln 7.
Yeah, I thought it was ln 7. Put in ln 7 into calculator, see if it's the same as that decimal you got earlier.
Yeah, it is, yeah.
Okay, great. Yeah, let's see. So, yep, this is exponential, and so I'm not surprised that we got something to do with ln or an exponential. Yeah, integral of 1 over was ln. Other than that, just remember log rules. I think it's all right. Unless you have any questions. So this one up here. All right. They're getting weird. They are getting weird. Ah, now I find it. I found one down the bottom. That's good. Is the top one worth doing?
I may be okay.
So let's. The one little thing is. Let me think. I won't. This question 6. I should have done this earlier, but I didn't see it. Okay, any idea how we go about this one?
Okay. So they're mixing x and theta here. So I see that arctan is in their answer, so should I then do theta equals to arctan x?
You mean x? So let x be equal to like arctan theta or something?
Yeah.
Okay. No.
Wait, sorry,
Tan theta?
Should I be differentiating tan theta?
Well, the last one we saw, we should have let it be equal to sine x, because it all cancelled out in the actual integration. And it made arcsine at the end. So let's go with this one. Go on, you could differentiate it. Do you know what the derivative of tan x is?
I was going to go from like first principles and go like sine x over cos x and so on. So.
And then quotient rule type of stuff. But the integration version of that. Yeah, if you know how to do that. Let's see. So This is the derivative. Oh, we want the derivative, don't we? So sec squared x, sec squared theta. That's from the formula booklet. Okay, so it was a sec squared theta. Yeah, I would always look up the formula booklet for trig.
Yeah.
You know, they give it to you for a reason. Like, imagine you spent a long time trying to. I think you'd probably not be able to very quickly. Actually, I don't know how you'd like quotient rule for integration, but I don't think there even is. Oh, I'm sure there is, but I don't know it. Okay.
And so now we do, dx equals to sec squared theta d theta.
Yeah.
And so now, with our equation, should we then be doing 1 over 1 plus tan theta squared times sec squared theta?
Let's see. So if we let x be equal to tan theta, 1 plus tan squared theta, is that what you said?
Yes.
Okay.
And so here we have sec squared theta over 1 plus tan squared theta.
Yep.
Which will be cos theta times cos theta.
Let me see. That's long, man. There's something that we should remember. Neither of us do. Sine squared theta plus cos squared theta is identical to 1. See if we can get something to do with tan squared. What would you have to do?
Do I need to divide both sides by cos squared theta?
Yep.
And then I'll get tan squared theta plus 1 is the same as sec squared theta.
Yep. And so no, that's good. I think, is that good? Yeah, that's what we should have. So, wait, sorry, come on, blue. Tan squared theta plus 1 is sec squared theta. Apply it.
And so, sorry, what was it? What was it the same as?
Tan squared theta plus 1 sec squared theta.
Yeah. So should I be doing sec squared theta minus 1?
So what is tan squared theta plus 1 same as?
Sec squared theta.
What is 1 plus tan squared theta same as?
Sec squared theta.
Yeah.
And will that just be cos squared theta?
Why do you...
Sorry, fine, it's 1, it's 1.
There you go.
And we now need to go back to our x equals tan theta, don't we?
In a minute. Integrate first.
So 1x, or just x.
With respect to theta. If it was dx, it would be x d theta.
Sorry, theta.
Yeah. And now you can go back to the thing.
And so now do I just sub in theta for tan theta?
X equals tan theta. Theta equals?
Arc tan x.
Yeah.
Does that mean the opposite result tan x plus c?
Yeah, arc tan x plus c, and that's what we were supposed to get. Yeah, great. Okay, so big picture. Well, they told us x equals tan theta. We sub it in. Let's see, get rid of all the x's. And with these, it really seems like if you try to do it yourself, it's gonna be like get crazy. But if you just do the easy stuff first, they tend to cancel out. Like I assume they've kind of made the questions like that. So everywhere you have an x, you replace it with tan theta. Then at that stage, it's like, well, I don't really know what to do. So then you would like do the bit you can do, differentiate, sub that in, and then it just works out. In this case, you had to remember trig identity 1 plus tan squared theta gives you sec squared theta. I never remember them, so I just kind of go back to this one and see. You only ever have to divide by sine or cos squared to get what you need. Let's see. All right. Unless you have questions, I think that's good. Let's see this one. U squared. Find this one. Oh yeah, so there was a part B, but then it's just substitution. Subbing in one, subbing the other, and subtract it. Okay. How could you start this one?
Would I make like u equals to 1 minus x squared cosine?
Trig substitution.
Is that like doing sine x equals to sine u or something? Or
yeah, let x be equal to sine. I'll just use theta because we used that.
Yeah.
And why did you pick sine?
I saw they have 1 minus x squared sine squared. I thought I could change that to cos squared or something like that.
Well done. Yeah, and that's what you should do. The square root of that is going to be cos theta. That other one is going to be sine squared theta. And when you change dx, I think it's going to kind of work out for us. That's good. Okay, there you go. Integration by substitution. Let me just go back. Where does one even begin with this stuff? Integration by substitution. Sometimes they give you the substitution. I thought they always did, but it seems like they don't. Yeah, there are so many steps to this thing. So what are the steps? Let's see. And so yeah, big picture is you're trying to replace every x with a u, like something x with something u, including the dx. Change that to du. That's what you're doing. I would say try to avoid square rooting or arc signing, that type of thing, because then you've got plus or minus, and you know, I don't really know what's going to happen there. Just do them in the easiest order, like the most sure order. Like you can do du dx, and sub that in. You know anything that you're sure of, sub that in, because these seem to always simplify part of the way, and then you don't have to, it makes it much easier. These were all right. It wasn't quite what I thought. Let's see. Yeah. That one subbing in, good. Yeah, don't forget, and I think you're pretty good at it, the limits that you have to change. Once you change from dx to du, you have to change the limits from the x limits to the u limits. We did exponentials. Just remember that 1 over x becomes ln magnitude x. So it seems like that's common with the exponential one. Trig one, they used a bit of trig identities. That's all right. This stuff, just, yeah, there's like 3 x's, sine cubed x, cos squared x, and dx. So the easiest one first is cos squared is u squared. Don't know what to do at that point, change the dx, and then that caused the other one to cancel, and then things got much easier from there. So just do the one you're most sure of first. Yeah, what do you give yourself for that stuff?
I think maybe a tick.
So that's supposed to be very difficult, but I thought it was all right. Let me see. So next is integration by parts, which is supposed to be, again, pretty brutal. I taught it last week and it wasn't fun, but we'll see how it goes. Yeah, how was that for you, Andrey?
Yeah, I was good, thank you.
By parts next time?
Yes, please, yeah.
All right. Any questions from me in general?
I don't think so.
All right. So if anything changes regarding school or whatever, like with the, exams and all that, you can just let me know. Or if you have like a big exam coming up and it's on some specific topic or whatever. I know your thing isn't, but some people have, like, we're doing just a test on binomial expansion or something, and so we do that type of stuff. But anyway, yeah, well done, Andrey. You did great, and I look forward to chatting again on Friday.
Yeah, thank you. See you on Friday.
All right, take care. Bye bye.